Now, this module is about complexity, and this is a fairly short module because I'm going to refer you to some material online that's in a lot more detail. But remember, the theme of this section is managing for change, and an understanding that we live in a very complex world and very little of what we do is simple anymore suggests that we better know something about complexity theory and how it applies to what we do. Now, there's really just two topics I want to hit on in these couple of slides. First is just to introduce you to complex adaptive system theory. Just so you know, you've probably heard the term before, but you might not have known exactly what it is. So I'm going to give you some really good definitions and point you even to some other material if you're interested in this. And then the second thing that might actually mean even more to you is something, it's what's called a sense-making model that's based on complexity. And it's specifically for decision making. It comes out of management schools, but I think you'll find this interesting. So I borrowed the next couple of slides from an introduction to complex adaptive systems from the innovation labs. But here's the gist of what you need to know. First of all, characteristics of a system. I'm going to start on the left and move to the right. A combination of things that form some unitary whole. Sound like anything that you live in? Probably sounds like everything you live in. Now here's what's interesting is number two. The behavior of the system cannot be predicted by the behavior of its parts. You can't, the sum of the parts is not equal the whole. It does something different. So that's why a lot of the examples that we see are things like ant colonies. You can't know what an ant colony is going to do by studying an ant, because they do things collectively that you would have never guessed from looking at a single ant. So that this is what makes them interesting. And they're characterized by positive and negative feedback loops. They are either encouraged to continue a behavior or to diminish that behavior. Now, as you move across, I'll leave you to read what it says about adaptation and evolution. But when we get to the right, we talk about complex adaptive systems are composed by a number of agents, and these agents usually follow simple rules. There's usually some kind of a goal or an emergent goal. And it's interesting that these complex adaptive systems are capable of predicting the future. They usually have certain control mechanisms. And you think about, well, why are we talking about this now? Well, think about something as simple as the relationship between what it is that you do in your organization, different government laboratories, your customers, vendors, suppliers, all these sorts of things are all pieces of the complex adaptive system that we all live in today. Now here's a better way to look at this. Start on the left. Think about multiple agents that compete, cooperate, collaborate. Think about the world you live in today. Think about different government agencies. Think about the different layers of government that we work inside of. Think about the industries that we cooperate with. Think about who our customers actually are. These are all parts of our complex adaptive system. Now, for each of these, we can model individual strategies. Not everybody thinks exactly the same way about the same things. Really great example, right? You'll have vendors who will try to convince you as government that we're all on the same team, we have all exactly the same goals, which is not entirely false, but is not entirely true. Every vendor has one specific strategy in mind that hopefully nobody in the government does, right? They have to make a profit. They're in a business. They have to make a profit. That may change their behaviors in some ways. They may make decisions a little differently because they have to make a profit that you wouldn't have made as the government person. How many times have you had to make a decision as a government person that may not have had a good cost basis at all, but it was just the right thing to do, and so you had to do it? So this is the sorts of examples that we're talking about where all these different strategies can be modeled. And then this creates different sorts of responses and outcomes as these different agents interact with each other, which collectively yield some emergent system behavior and some kind of changed environment. And most importantly, what happens is you end up with adaptation, right? So when Congress changes the rules and says, hey, we don't like the way acquisition is working today and we want to do acquisition reform, the acquisition environment is going to adapt to that. Not necessarily to overcome. Hopefully we're going to do what Congress wants us to do, but we have to adapt. We have to change what it is we're doing so that we can still meet our mission. And so this is how a complex adaptive system works with these multiple agents that model individual strategies that result in responses and outcomes and this is where the catch between those responses and outcomes and the emergent system behavior that cannot be predicted by the individual strategies, which then results in some type of adaptation of the individual strategies in the multiple agents that again will evolve the system as a whole. If complexity theory is something that interests you, I highly recommend you visit the website of the Santa Fe Institute. This is their bread and butter. They are famous for complexity. They actually have a recent course specifically on complexity that I can recommend to you. It really rolls up your sleeves and gets you dealing with complexity and understanding it and how it relates to the real world. Extremely useful. Now, last thing here I want to talk about is this decision-making model based on complexity. So let's apply this to decision-making. And I'm going to point you to a video on this. This is something called the Sinafin, I think I pronounced that correctly, framework by Dan Snowden. And the best way to describe this, we're going to start in the lower right-hand quadrant called simple. First of all, notice that the way he builds this model is he doesn't use straight lines, and that's not because he's trying to be artistic. It's because he's trying to make the point that we don't often know where the boundaries are between these different categories. But let me just sort of talk through what they are, and he'll describe them even better. But in the bottom right is something called simple. We often assume everything is simple. You've heard of best practice, right? You may have best practices in your organization where we know what the relationship is between cause and effect. And so all you really have to do is sense. You have to look at a problem. That's sensing. You got to categorize it and say, oh, that's like this. And then respond using the best practice. Hey, when that happens, we do this. That's simple. Okay? We try and act like everything's simple, but it isn't. So the next one up is called complicated. This is where the relationship between cause and effect requires some analysis or some form of investigation that involves some expert knowledge. So now it's a little bit different. We're still going to sense. We're going to have to take in inputs and say, what's going on here? We're trying to make a decision, right? But we can't necessarily categorize it because it doesn't just fall in a bucket. We have to analyze it before we can respond. So this is something that we call good practice. It's sort of I can't just go to the practice tree and pick the best practice off that fits my problem, and I'm going to know that everything's going to work good. What I have to do is now I have to have a good process by which to develop a good practice, which may not be the best practice. Next, upper left is what we call complex. So the relationship between cause and effect can only be perceived in retrospect. So now you're looking back on things that you've done and saying, hey, does that work or not? So now you can't just sense something. It doesn't matter to go and collect lots of information about your problem. You have to actually probe it. You got to try some things. You got to say, what happens if I do this? Right? So remember when we were talking about disruptive technology, right? That's a complex or maybe even chaotic environment where there's no amount of planning that's going to fix it. You got to probe it. You got to figure out. You got to make little investments to figure out what's happening here, so that you can then sense what comes back when you probe, and then respond. So this is what we call emergent practice. And then the last thing is what we call chaotic, which is novel practice. So this is where no matter what I do, I can't even determine a relationship between cause and effect at the system level. So here's where I'm just going to act. I'm just going to do something the best I can, right? And I'm going to sense what's actually going on, and then I'm going to just evolve what I'm doing towards something that's better. So I'm going to use sort of like a hill climbing technique in order to make my initial decision, which may not be very good because I can't make it any better initially, and I'm going to make it better over time. So now I'm going to point you to a couple of videos and some things online that are going to go into a little bit more detail on these topics. But I think you'll see immediately how some understanding about complexity is useful for all of us in modeling and simulation. Our world is complex, and in fact, we are being asked to model complexity increasingly. It happens more and more where people are trying to use what we're doing to look at complex environments, and we need to know what the boundaries are between things that we can model with predictable outcomes and things where we can only possibly provide some insight. This is where complexity comes into what we do.